Assalamu alaikum wa rahmatullahi wa barakatuh. Hi guys, this is Science Lessons Grade 3. Again, Grade 3 Science Lesson, and let's start. Today, inshallah, we're gonna complete Lesson 2, Chapter 2. Okay, so this is Session 2, Lesson 2, Chapter 2. How does energy change forms? You're gonna find this lesson in the booklet page 44. So last session we talked about energy and energy transformation and how energy changes its forms. Today we're gonna talk more about how energy travel from one place to another or from one object to another. So let's watch this video together to know more about our lesson today.
Energy can be found in many different forms. It can also change from one form to another. Sometimes people change the form of energy by using machines. When you switch on a light, electrical energy changes into light energy. Energy does not completely change from one.
So I have a question here. Can you tell me, when we use this light bulb, electrical energy change to who can tell me two kinds of energy or two forms of energy? Electrical energy change to super light energy and heat energy. Good job. Why? Because this light bulb get hot. So this means some of energy change to heat energy. Good job.
When the bulb stays on, it becomes warm. Here, the light energy also produces some heat. Another common machine is a CD player. A CD player changes electrical energy.
Okay, can you tell me the CD player change electrical energy to what kind of energy? Super sound energy. We can hear it. Good job. Okay, let's continue.
Into sound energy. Both sound and light energy travel as waves.
So this is our lesson today. We talk about how energy travel. So this is how energy travel from one point to another point as a wave. Again, as a wave. Do you ever go to the sea? Yeah, of course. So you know the waves of the water. Yeah, the waves of the sea. Excellent. So energy waves look like look like the sea waves. So let's know more about energy wave.
Wave is a disturbance that carries energy from one point to another.
So as you see here, wave is a disturbance. Disturbance, what the meaning of this? This line was stable. Then what happened? Disturbance. Go up and down, up and down. So this is a wave. Disturbance. Carry energy from one point to another.
The shape of a wave can tell you a lot about the energy it carries.
So the shape of the wave tell you how much energy does this wave carry. Okay, if we look here, this is slowly wave. It go up and down slowly. So it have a little bit. So it have a little, okay, little amount of energy. But here, this is a very fast wave, up and down very fast. So it have a lot of energy. So let's continue to know more about the shapes of the waves.
Since sounds are hard to see, look at the waves in water.
Okay, so as you see here, the waves of the water here is slowly. This means it have small amount of energy. But if the wave is huge, big wave, and it's fast, so this means it's fast and huge. This means it has a big amount of energy. So let's watch together.
When waves are small ripples, they have less energy. When the waves are bigger, like in a hurricane, they have a lot of energy.
Wow. So as you see here, it's a very big wave. This means it have a lot of energy. Good job. So let's move to the booklet page 44. Now we talk about energy and how can energy travel. Energy can travel by cars? No, energy can travel as waves. As waves. You can travel using a car, but energy can travel as waves. A wave is, again, this line was stable and straight, nothing happened. But when this girl tried to play with the rope, what happened? A disturbance, as you see, disturbance, okay? Disturbance that carries energy from one point to another point. Again, disturbance that carries energy from one point, here this point, to another point, here this point. Okay, so light and sound travel as waves. Why? Because light and sound are energy, and we said before energy can travel as waves. Okay, so energy moves along the rope, as you see here. This girl or boy, I don't know, have a rope, and this rope tied to the tree. And when this child play with the rope or move the rope, what happened? Yeah, excellent. Disturbance means not stable anymore, not just a line. No, go up and down, up and down, up and down. And energy, kinetic energy, move from this point to this point. Excellent. Okay, and those are waves too, but we can't see them. We just draw them, but really we can't see them. Those are something like Wi-Fi. So if you have a router at your home and you needed to turn on or log on to the internet, so it make waves like this waves, but you can't see it. Like sound waves, you can't see it. Okay, the wavelengths. Okay, let's first know more about the wave. This point in the top, or the top of the wave here, the top, the highest point of the wave, we call it crest. Again, crest. So the highest point or the top of the wave, we call it crest. So we have here one crest, two crest, three crest. Okay, and down here, the lowest point of the wave, down here, the lowest point, or we can see it's the bottom of the wave, the bottom of the wave. This is trough. Again, trough. So we have here one trough, two trough, three trough. Excellent, good job. Okay, and this, the line before we play with the rope or move the rope here, can you see it? Yeah, this line, guys, we call it midpoint. Here in this point of this line, we call it midpoint. Midpoint, it's in the middle between the crest and trough, midpoint. And if we measure the distance between the midpoint and trough, or the midpoint and crest, we can know how big, okay, or how high is this wave. And we can know if it's so big or so high, so we know that it has a lot of energy. But if it's small, we know it has small energy. Okay, so the distance, as you see here, the distance between two crests, let me use the marker. Yeah, this distance between two crests, or the distance between two troughs, we call it wavelength. Wavelength, how long this wave is. Again, wavelength. How can we know the wavelength? We can measure the distance between two crests, the crest and the next crest, or the distance between two troughs, this trough and the next trough. So this is wavelength. Okay, if wavelength is big, this means it's a slowly wave, and this means it have small amount of energy, it have less energy. Again, if the wavelength was big or long wavelength, it means it's a slowly move slowly, so it have big wavelengths. This means it have less energy. But if the wavelength was short, this means the wave very fast, up and down, fast. So this means it have much bigger amount of energy. It have a lot of energy. So let's read. The wavelength and the distance indicate how much energy the wave carries. So if we have, again, big or long wavelengths, this means it's a slowly wave and have less energy. But if we have short wavelengths, so this means that, yeah, the wave move fast and excellent, it have a lot amount or a lot of energy. So let's read together. Trough is the bottom of the wave. As you see, trough is the bottom of the wave. Okay, let's move to the next page. Okay guys, let's watch this video together to know more about the wave.
Waves. One of the first things we need to know about waves is there are two different types of wave. One, shown here, are waves in the sea, and the other one shown by sound waves. So how are they different? Well, first let's look at the sea waves. If we look at them represented with this slinky, the travel of the wave. These are called transverse waves. An example, now let's look at the sound waves again, is power, and the only example you really need to waves is they only transfer energy from place.
So again, waves only transfer energy. We talk about energy waves, not the sea waves. No, energy waves. Waves only transfer energy. Okay, so like your mobile make waves to help you listen or help you listen to your mother when you call it. You can see the waves? No, you can't see the waves. Okay, those waves transfer just sound energy, or transfer or change or travel with the mobile, or transfer the mobile, take the mobile from this place to another. No, don't change the position of the mobile, just transfer or carry energy to the mobile or out of the mobile. Again, waves, energy waves, don't change the position of the objects. No, just change or carry energy. So let's watch this together to know more about waves.
To place, not any matter. And we can see that here by looking at a lovely rubber duck sat in a bath. As a wave goes through, the duck bobs up and down, but once the wave's gone, he's back to his original position. The wave has carried energy through, but it did not carry the duck with it.
So again, waves can carry energy from this point to this point, but don't carry the duck from this point to this point. No, just carry energy. Okay, so let's continue.
Finally, we need to know some key features of waves. First off, wavelength. A wavelength is the length of a full cycle of a wave, from one point to the next same point.
Okay guys, so as you see here, we have here what we call this part of the wave, trough. Excellent. In this part, crest, and this part, trough, crest, trough, crest, trough. Excellent, good job. And the distance between two crests, we call it wave length. and the distance between two troughs. We call it wavelengths.
It's easiest to think of as the distance from crest to crest or from trough to trough. And we measure it in meters.
So guys, this is the midline, and here you can see midpoint, 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 and this is trough, crest, trough, crest, excellent, trough, crest, trough, good job. Okay, so let's move to page 45. Can you tell me what the meaning of crest? Here, the top of the wave. Good job. Okay, again, what the meaning of wavelengths is the distance between one crest and the next crest, or one trough and the next trough. Okay, let's look here. One crest and the next crest. Okay, or one trough and the next trough. Okay, guys, so look at those three kinds or three different waves. Okay, this is wave here. Okay, this is number 1, this is number 2, and this is number 3. Okay, we have here the biggest wavelengths. So big, and this wave is slowly, as you see. Here we have not so big, smaller than number 1, smaller wavelengths, and it's not so fast but not so slow. Here the wavelength is the shortest, and the wave is fast, up and down, fast. Can you tell me which one of those three waves have the bigger or the highest energy? 1, 2, or 3? Can you tell me? Again, 1, 2, or 3? Super! Number 3. Why? Because it's so fast to have the shortest wavelengths. This means it have the highest amount of energy, the highest energy. So shorter waves or shorter wavelengths have high energy. Again, shorter wavelengths have high energy. Good job. It's so fast. It have a lot of energy. The shape of the wave tells you how much energy it carries. Yeah. So here, small energy, bigger than number 1, the biggest energy, or the highest energy. Higher waves have more energy. How we know the wave is high? How we know the wave is high? Let's back to this part here. You remember? From the midpoint to the trough, or from the midpoint to the crest. This is how we know if the wave is high or low. So let's back to this point here. Yeah. Higher waves have more energy. So if we draw the line here and we take a line from this midpoint to the crest, we're gonna find this is the highest wave. This means it have the highest energy. The energy a wave carries can change. Yeah, if you look here, those first or those the waves close to the center here, so high. So this means they have the highest energy. Excellent. Okay, so waves here have more energy, but when we go outside, you see those small waves here. Those are lower waves, and they are so slow, and they have less energy. So again, waves in the middle, they are high and fast, and they have more energy. Waves here outside here, it have less energy. Why? Because it's slow, low. Here if we measure it, we find those are low, yeah, like this, low, and they have wavelengths, more wavelengths. Okay, so they have the most wavelengths here outside. I hope you got it, and this is page 46. We're gonna answer some questions together. Number one, exercise number one, circle the word that correctly completes each sentence. Number one, energy can travel in the form of, okay, let me just choose my marker, waves or wavelengths. Waves, super, good job. Number two, the distance between the midpoint here, this is the midpoint, and they what? Wavelengths or crest, helps show how much energy a wave has. Crest, good job. The line between the midpoint and crest here. Okay, super. Number three, they crest or trough is the lowest point of the wave. Here, the lowest point of the wave, it's trough. Good job. Number four, you can measure wavelengths or midpoint by finding the distance between two crests. Here, the distance between two troughs, like this, or the distance between two crests. This is wavelengths. Good job. Okay, label the parts of the wave below. Let's see. The top of the wave, trough, crest, midpoint, or wavelengths. Trough. Good job. So no, not trough, teacher. I'm sorry, guys. It's, yeah, crest. Good job. So let's erase those lines. Okay. And back to the marker. Okay, so the top of the wave, it's crest. Good job. So this is crest here. The bottom of the wave, trough. Good job. So we're gonna write trough here. Okay, this point we call it midpoint or wavelengths. Midpoint. Good job. Okay, last one, the distance between two troughs, we call it wavelengths. Excellent, guys. So this is number 4. Okay, I hope it's so easy for you and you got it. So time now for new words. Come on, come on, come on. The first word, the disturbance that carries energy from one point to another. What carry energy from one point to another? Car, train, or wave? Wave. Good job. Like here, the waves of the Wi-Fi. So let's clap for you. Good job. The bottom of the wave, this point, the bottom of the wave, trough. Excellent. The top of the wave, crest. Super. Last word, the distance between one crest and the next crest, or one trough and the next trough. The distance between one crest and the next crest. What do you think? Wavelengths. Good job, guys. Well done. Okay, this is all for today. See you next time, inshallah. Bye.